Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial, I'll go through these assorted examples involving the periodicity, meaning the periodic table, which start off from atomic structure and then links to chemical bonding, metals, non-metals, basically everything about the periodic table. This is for the combined science chemistry. This is the 5129 syllabus, which is also related to the IGCSE combined sciences. So if you are year 11 students, basically towards the end of your 14 to 16 years of curriculum, this tutorial might be helpful for you. In this first question, we have a nuclide notation. So this nuclide notation is something you would know as the international standard. It is not the same as whatever is given in the periodic table, and you must be aware that this is what exam will give you. So in your periodic table, this is given for you in the periodic table. They will show you the symbol for the element, and they will show you the proton number in the middle. So they call it proton. Well, they call it atomic number. And then there is a different number on top. I'll just label B. It is not Z because this number, as stated in the periodic table for free, is called relative atomic mass. So relative atomic mass is not this symbol here. You will see that this is the periodic table standard. The numbers are in between, in the middle. When you write nuclide notation, which is the international standard, you are writing the proton number at the bottom. So the smaller the number it is at the bottom, this is proton, or known as the atomic number. This number on top for this international standard format is called nucleon number, or you can also call it mass number. Now they are giving you the options to choose from this list. You can choose each word once, more than once, or not at all. So X is the symbol for the atom, because each and every single thing shown in the periodic table belongs to an atom, as shown in the question here. If I'm not mistaken, the accept element technically is not correct because, well, I suppose you can write element as well if you want to, but it's not entirely correct because it's simply showing for one particular atom. Now this number on top is mass or nucleon number. Out of this option here, there are no masses, and they say use words from the list. So you don't come up with new terms, you just use whatever is on the list. So the number on top, there's A, is called nucleon number or mass number. The number at the bottom will be the proton number or the atomic number. So there's no atomic number given the option, I'll stick with proton. There's no mass number given the option, I'll stick with nucleon for that 2 marks. In this second question, again, is fill in the blank and use words from the list. So we have atoms are made out of nucleus. So if you know the center of an atom, this is the center. The center of an atom contains the nucleons. So both of these particles, these and these, are what you call nucleons. Nucleons refer to the particles in the nucleus of an atom. They consist of protons and also neutrons. So the protons and the neutrons are in the nucleus in the middle, and they are surrounded by electrons in shells. So the electrons are in the shells outside. When you draw those crosses, you are drawing electrons in each of the shells that surround the nucleus, outside the nucleus. In a neutral atom, so no charge, because the number of protons equal to the number of electrons. As you know, protons have a relative charge of +1. Electrons has a relative charge of -1. So the charges cancel out if and only if the number of protons equal to number of electrons. You could have gotten electrons and protons here. That would be correct as well, because number of protons equal to number of electrons is the same as number of electrons equal to number of protons when you have atoms which have no charges. In the next bit, when your atom become negative ion, how does atom become negative ion? As you know, negative ion come from non-metal. As you know, non-metals are found on the right-hand side of the periodic table. To complete your outer shell, you gain electrons. So what we're saying is the atom will gain electrons, but you are still the same nucleus, meaning your nucleus still contains the same protons. So protons doesn't change, but you have gain electrons. Gain means you accept, you receive, therefore you have extra electrons. Remember, electrons are negatively charged, protons are positively charged. If you have more negative charge than positive charge, then you will get negative ions. Next bit, when you have ionic bond, as you know, between a metal and a non-metal, something is something by the metal. So what happened to the metal? Metal will lose electrons and they will form cations. So cations are positive ions. In part 3, that was what happens with the non-metals, non-metal atom. So non-metal atom on the far right of the periodic table, they gain electrons to give you negative ions, the other name of which is called anions. Therefore, in this ionic bond between a metal and a non-metal, the metal will lose electrons, so electrons are lost, and then you will get positive charge, metal cations. So it's metal cations and non-metal anions for the previous example. That's it for that 4 marks. Question 3 is a perfect example of what we had said earlier. So this is the nucleus of an atom in the center. So if you count this, so the particle inside the nucleus is what you call nucleons. The nucleons in the nucleus. The whole position, the place is called nucleus. The particles are called nucleons. Nucleons consist of protons and neutrons. If you look back at this 15,7 nitrogen, which is given in the question, this is the nuclide notation, the international standard. The number at the bottom is called proton or atomic number. It tells you the number of protons in the nucleus. So there are 7 protons. If you count the black stuff, there's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of that black stuff. It cannot be protons. The black stuff is not protons because you have 8 of the black stuff. You count again, 1, 2, 3, 4, 5, 6, 7, 8. You cannot have 8 protons since you only have 7 protons for nitrogen. But the white color stuff, 1, 2, 3, 4, 5, 6, 7, you have 7 of that non-bolded stuff. So that must be your protons. So B must be protons because it's not the darkened stuff. Then what is this other darkened stuff then? Nucleons. Nucleons are defined as protons and the neutrons in the nucleus of an atom. As you know, how do you know there are 8 neutrons? Because this on top is what you call nucleon, or we can call it mass number. So nucleon number minus the proton number will tell you the number of neutrons. As you know, nucleon number is equal to proton number, basically the number of protons plus the neutron number. So usually to get these, we do the number on the top, nucleon number, minus the proton number. So if I want this, I can move this to the other side, so I can get neutron number, basically how many neutrons there are. I do a little bit of simple math, so that one minus the proton number. So the number on top minus the number at the bottom will give us 8 neutrons. In fact, that was what we have done. We have named the particles. Now they say this atom was nitrogen 7 and 15. This is an atom because the atom has no charge. So you have 7 protons and 7 electrons. There are 2 bits to this question. That's why there are 3 lines and there are 2 marks. If you read the question, they say it forms an ion with N3 minus. First of all, describe how it is formed. So the atom become N3 minus. N3 minus, this represent anion because it's negatively charged, and you have a 3 minus because you have gained 3 electrons. If you think about the outer shell electrons, 1, 2, 3, 4, 5. There are 5 outer shell electrons because nitrogen is in period 2, but it's in group 5 as given in the periodic table. Group number tells you how many outer shell electrons do you have. Group 5, 1, 2, 3, 4, 5. Nitrogen is basically 2, 5. Now you will gain 3 electrons and it will become 2,8 to have a fully filled outer shell, and that's the reason why this ion is stable, because you want to gain 3 electrons to become a fully filled outer shell. So first of all, describe how you form it. So the nitrogen atom, basically this one with a 2,5 electronic configuration, 2,5, gains 3 electrons to form N3 minus anion, or just N3 minus ions. On to the second bit, why this ion is stable. Stable ion because you have a fully filled, because it has fully filled valence shell. If you have never used this word valence, V-A-L-E-N-C-E, you can use the word outermost. They mean the exact same thing. Outermost refer to the one which is most outside. Valence refer to the one which is most outside. Now complete this table. This is straight from the syllabus. This is a year 9 syllabus, and you are also required in your syllabus. Candidates should be able to complete this table. Electrons are negatively charged, as you could see that. Protons are positively charged. Neutrons have no charge. In terms of masses, mass is not charged. Charge has plus and minus. Mass has no plus or no minus. It's always positive. Neutron has the same mass as proton, so they have the same 1 and 1. Electron is the lightest. Electron is roughly 2,000 times lighter. So there is an exact answer for this, but it's enough to write 1 over 2,000 to save your memory of having to remember the exact number, which is around 1 over 1846 or 1 over 1856. I can't remember the exact number. I always remember it's about 2,000 times lighter, 2,000 times less heavy. Less heavy means 1 over 2,000 because it's lesser than 1. That's it for that 2 marks. In the next question, number 4, so this is a question about isotopes. They say these atoms, not 3 atoms, isotopes of the same element. How the data in the table, very, very important, data in the table. For that 2 marks, you are asked to define isotopes, which is part of your syllabus. Candidates should be able to define isotopes in terms of same number of protons. They say use the data in the table, so they give me protons, neutrons, and electrons, so I have to say same number of electrons as well, because use data in the table. So these atoms, what is it they have? They are the same. What is it they have? They are different. They have same number of protons and electrons, but what is different? Okay. So now I need to focus on what is different. As you can see, these are 8, 9, and 10 neutrons. Protons and neutrons are the nucleons. They are the particles in the nucleus of an atom, whereas the electrons are in the shells outside the nucleus, or you can say surrounding the nucleus. So what happened is, but these and these have the same number. These neutrons are different, so but different number of neutrons. So do not confuse how many you have with where you can find them. Be very, very careful. You don't want to lose the 2 marks at all. In part B, so you have an atom of zinc. We know the number at the bottom represent proton number or atomic number. This is international standard of the nuclide notation. The number on top is the nucleon or the mass number. They mean the exact same thing. How do I work out neutron number? Nucleon number minus proton number. So 65 minus 30. Pop that into your calculator without wasting any time. You can get number of neutrons because this is nucleon number. So this is number of protons plus number of neutrons minus the number of proton which come from the proton or the atomic number. State the number of electrons. They want the electrons, and they have this keyword atom. Atom has no charge, and because you have no charge, so the number of protons must be equal to number of electrons. So very straightforward. You look at the number of protons being 30, so you must have 30 electrons as well. Now we look at these, we know that these are metal. They are not in the common place for metal on the far left of the periodic table. In fact, zinc has the symbol Zn, is found in the middle of the periodic table. They tell you that this is a cation because they show it as positive charge. So you get positive charge by losing electrons. So when you lose electrons, you have a +2 because you lose 2 electrons. So you lose 2 electrons to get +2. So therefore, you started with 30 electrons for the atom, -2, because this is a plus charge, you lose electrons. That's the number one mistake by students. They thought that losing electrons mean minus charge. They thought that plus charge mean gain electrons, but we know that's not true. Metal cations, through the loss of electrons, losing 2 electrons, you get 28 electrons remaining for the zinc 2 plus ion. In the next question, so we have electronic structure of an atom of chlorine. So what does this electronic structure tell us? Sometimes they call it electronic arrangement. Sometimes they call it electronic configuration. So they all mean the exact same thing, whether it's configuration, arrangement, or structure. So what we can say is this is the first shell, and then it followed by the second shell, and then followed by the third shell. As we could see, the first shell and the second shell is fully filled, so the third shell is not completely filled yet, and the third shell is the outermost shell. And how many electrons are there in the outermost shell? So there are 7 valence. If you don't like the word valence, you can stick with outermost, but you got to know each and every one of these meaning. So therefore, 7 valence electron mean group 7 as told in the periodic table. On the other hand, this outermost shell electron is 1 valence, or outermost electrons, therefore this is group 1. As you know, period 3 is the third row of the periodic table. Group 1 is going downwards, is group 1, and they want the formula, they don't want the name, they don't want the configuration, they want the formula. This is a metal atom. Metal will want to lose electrons, so sodium become sodium plus because 281 become 28. You lose the 1 outer shell electrons, and therefore you get Na plus. As for Cl minus, so well, Cl is 287. They gain 1 electron to complete the outer shell. You get Cl minus, which is 288. So it's Cl minus because you gain 1 electrons. This is a recurring example of the type of questions that always come out. They're asking you why the sodium ions and chloride ions are stable. You got to focus on the outer shell. We talked about the outer shell just now. What is the purpose of you gaining 1 electron here? Why not 2 electrons? Why do we lose 1 electron and not any other electrons? Because this was in group 1. So it wants to complete the outer shell by losing these outer shell electrons. So now, both the Na plus and Cl minus have fully filled outer shell. This is very, very important. They have a fully filled, or they have a full outer shell, outermost, or I could use the word valence, whichever one you like, stick with 1. They now have fully filled outer shell, Next one is a structure question for 2 marks. You really must know properties of ionic compound. These are in the syllabus. They say candidates, all-level combined science students should be able to state 2 properties of ionic compound, and one of them will be high melting and boiling point, because you are breaking strong ionic bond. But they are not asking for a reason, they are asking for stating, so you don't need to explain because it's only 1 mark for this. And another mark is ionic compound can only conduct electricity. So you do not conduct electricity when you are solid, because the ions cannot move, they are not free to move. They can only conduct electricity in liquid, basically molten state, or when you dissolve in water, or when dissolve in water. When you dissolve in water, that is called aqueous state, aqueous solution, aqueous state. The last bit of this question to get the full 5 marks, why chlorine is placed in group 7. So we know chlorine is 287. This was given earlier in the question, 287. And we know it was a result of the outermost shell electrons. So chlorine atom has 7 valence electrons. So that's it for the first 4 pages of this tutorial. Don't forget to click the button on the bottom right to subscribe to the channel and follow me at ptet.chemistry on Facebook, Instagram, and Twitter to get connected, and yeah, check out my other tutorial videos that will continue this tutorial in the same playlist. Thank you for watching.